Hey, welcome back. I wanted to try something a little different this week. I'm going to do it kind of out of order. Next week, I'll look at installing some like local models. But this week, I just wanted to play around with some models that I already installed. Um, and I'm just checking the stream, making sure that there's sound, that there's some video. It seems like we're good to go. So I'm using this JupyterNaught. It's kind of a combination of tools. So I have Ollama running in the background. So let's do a quick, oh, no, that's Ollama. And then within Ollama, there's all these different large language models that we can get up and running from there. And next week, I'll go through the process again and record it just for myself to figure out like how did I even get there. But the reason that I started doing this was that DeepSeek that one's kind of making waves right now of like, wow, it's all this great stuff, and you can grab that and have it running locally on your own computer, so you're not logged into a server somewhere in the world giving them information about whatever you happen to be doing. In my case, most of the time I'm looking at textbook problems as an educator, but I could use this for any other kind of model, any other kind of like yeah, like work and all this other stuff. So I have Ollama running, and then I installed this extension in Jupyter Lab so that I can actually interact with it, and I can change. So here I have Ollama chosen as my thing, and then this DeepSeek Coder V2. Is that the one? I think I wanted R1. Let me see if I can change it. DeepSeek Coder R1. Let's see if this will work, or if I'm gonna break it. So let's ask a question. Well, let's just ask it. So one of the things that I ask students to do is give me an implicit integration method, and ChatGPT keeps giving some weird answers. So let's ask it again. I need an implicit integration function. I can't spell. And shift enter to send it. Ooh, yeah. Did not like that. So let's go back. Change it to V2 again, because that one was working. And these I'll have to go through and look at what all of these settings are, because I can't remember what they are. So we'll go back to that. Let's try again. Just paste it in there. And now it's generating a response. And it does take a couple extra seconds because I'm running it on a laptop, so it's not as fast as using a web interface, but it's doing everything here on my computer, so I'm not sharing information with anybody. Oh wow, what's going on here? It's giving me some different characters. That's funny. I wonder why it switched over to a different language. And I'm not sure what it's saying. I mean, I can kind of guess based on. Interesting. All right, so let me try. Try again. I need a function written in Python that takes, that does implicit numerical integration, like that. Let's try this one. An ODE INT. This one does work, but I think this is the old version of, yeah, for new code use solve IVP. So that's kind of outdated advice, is using this ODE INT for integrating problems. It does work, but I don't think it has as many methods. Let's see. Yeah, I don't think it even lets me choose a what kind of integration method I can use, rather than with solve IVP. This one has an input where you can choose if you want Runge-Kutta or Runge-Kutta 2.3, or Redow, like an implicit, or another BDF implicit method. All right, so what did we get this one? Oh, let's try this again. I'm just playing around with this today and seeing what I can do with my little laptop running a large language model. So my guess is that this text is telling us that this code is integrating, and we could try it while we're thinking about it. We don't need the plot show. Let's see, what do we have? Implicit of y times sine of t, or y plus sine of t. Seems to work. Still working on the response. And again, a little slower because I'm running everything. It's still. I wonder if there are settings that I could change to get it back into English. Yeah, it gave me the same output. So let's see. Let's get my console up and running. Ollama pull, and I want to pull the DeepSeek R1. Is that right? DeepSeek R1. Because that's really the one that I wanted to play with. So this will pull in, it's kind of like downloading all the parameters for that model. And yeah, you can choose how many like billions of parameters you want to use. So there's like the colon 8 billion or the colon 7 billion or the smaller like 1.5 billion. But I'm just gonna try this to start. And this might be something worth fast forwarding as we download stuff. The problems of using the internet while live streaming. Am I still connected? I think so. Just slowly thinking about it. Let's come back here. Maybe if I call this DeepSeek-R1. And let's do a clear. I need a Python function that performs implicit integration on a differential equation. Oh. Yeah, so it didn't find it yet because I think it's still loading. I thought I had put this on there already. Let's see, DeepSeek. Maybe I was looking at DeepSeek-Coder. Oh, still no good. So let's see what list, Olama list. So I do have a DeepSeek-Coder and a DeepSeek-Coder V2. The Coder V2 looks like it's a little bigger than Coder. So what was it called? Coder V2. And then I think Lava was one that I was playing around with that will look at images for me. So I can say like, oh, Llama, describe this image, and tell it that I want to use that lava thing, and it thinks about it. And first I'll look at the description, and then I'll open up this image. And now I'm really stressing my computer because I'm asking a llama to do two things at once. Yeah, here we go. We're back to English. I don't know what happened. Maybe I just need to like disconnect and reconnect to so it's thinking. Give that a shot. And this one's also thinking. And we're downloading. We're doing all sorts of stuff. This poor little laptop isn't gonna see tomorrow. Oh, and this one's back to Solve IVP, which is, that one's the better. Oh, that's interesting. Why would you import Solve IVP and create your own function? Method trap Z, thinking about it. Thought this ran a little bit faster last time. But I'm doing a lot all at once. I think download is speeding up a little now. Yeah, that's weird. Like why define this big wrapper function for a solve IVP? Solve IVP is already a wrapper function for integration methods. This is a very strange way to do an implicit integration. Over here, let's delete that. What? Return y minus implicit step t comma y. And then fixed point, is that something that we, what is fixed point? No fixed point found, so where? t minus 0.1 to t. So we're taking steps of 0.1. So yeah, it spent a long time kind of building out this function for us and then left us with the advice of like, hey, you can use solve IVP, which is, I mean, that's where I would, if I was just going to do this anyway, I wouldn't do it step, what is T-span? Like, how does T-span get used? So we're using T-span with 100 steps. And then shouldn't this be T minus 100, like T-span over 100, I would think, like 100th of whatever time span that is. Because if we took 0 to 100, or whatever, 0 to 99, we have 1 second steps. This one is only half stepping back by 1/10 of a second rather than a full second. Oh man, this is so weird. And then it's updating, so t comma y0. So strange. Here, let's try to, this method, the method you gave, uses solve IVP, but I wanted an integration function that does not call solve IVP. I'm just giving it some can you rewrite the function as a implicit Euler integration for 1 time step. Maybe if we just restrict it to, rather than trying to do the whole thing. Oh, it's still downloading. DeepSeek-R1, the latest and greatest, right? Slowly thinking about it. But I guess we can paste this over here and take a look at what's going on. Let's make something a little more. I'm just doing like a sine wave kind of equation. Do 4, so natural frequency is 2. Unexpected keyword, but that was your own keyword, Jupiter. That was your own keyword, DeepSeek. So what did it do here? Where are we failing? Implicit solve t comma y. Doesn't like SOL equals fixed point. This, I don't understand the fixed point either. I don't know where that one, fixed point iteration. Oh, from SciPy, import fixed point. Got it. But maybe that doesn't have a tolerance value in it. Maybe it's some other word. Anderson. Yeah, it doesn't like the word Anderson in there either. So let's just see. Let's get rid of all those arguments. Residual and y0. NumPy array has no object x. Maybe not. No. How is fixed point supposed to work? Let's import it. What are we supposed to do with this thing? Dot fixed point. We can pass in arguments. We can give it a function and then an array. So maybe that's a problem. Maybe I need an array in there. Well, this one should be an array. So now over here, we're looking, it's still doing like a whole time span rather than like one time step at a time. But it is defining a residual, which is one thing that ChatGPT was not doing. If we come over here, ChatGPT, verifying. I'm human. And let's copy in the same prompt. Backward Euler integration. Yeah, this one, so ChatGPT, sometimes it ignores my command of like, hey, I want an implicit method. Other times it tells me you can use an implicit method by using fsolve. It's one way to do things. It certainly, it does work, because we can compare that to this one. I think we will at least like get some output. So then we look for the root of that residual. So looking for when that's equal to 0 or close to 0. I feel like usually that's how these implicit routines work. It's like you create a y new minus that y and figure out when the error between them reaches something close to 0. I mean, I guess technically if you find the root of it, then it is 0. It's when they're equal to each other. Y new is y. We can try that one in here. And instead of printing, let's do a oh. Why can't I grab the sol.y? I guess I have to do sol bracket t, like this, like a dictionary. And then bracket y, like that. No? Let's see output here. Okay. There's t. Is that y? There's y0, so maybe I want that. And let's change this ODE to something like y bracket 1 and -2 times y bracket 0. -4. And we'll go from 0 to 2 times np.pi over 2. 1 and 1. Shouldn't I see? I don't see any oscillation. like bounce up and down, right? But it's always the same answer. Oh, H is 0.01. Is that one used in here? Number T-span? Ah, because this is always 100. Shouldn't that be a function of H? H equals 0.1. I feel like we're missing a step, right? So it's using T-span, but it's not actually changing my time step, even though I'm telling it to change the time step. So let's just add an extra H equals 0.01 here. And now we'll say T-span bracket 1 minus T-span bracket 0 floor divided by H. And then we'll do +1. So we get one extra step in there. Yeah, try that. Oh. Just one too many parentheses. Float is not an integer. Had a feeling you were going to complain about that. So T-span, let's call it 0 to 10. And we'll say H is 0.01, just like we were trying to do. So I need to tell it specifically that this is an integer. All right, so take the whole thing, put that parentheses back that I just deleted, and then say this is an integer. And let's put that on a new line. Now we have a different error. Oh, H keyword args. Oh, because H was that. It was being used there. Oh, so let's just delete that and put H. Because it has a default value now. There we go. Whew, boy. All right. So now it should be 2 pi over 2. Gives us about and then if I change that 0.1, let's stop rerunning. Zero, 1. We should see some oscillations, and it's oscillating. Cool. So now we're starting to get a little closer. We're still using this like some kind of root function, and that one in the ChatGPT, instead of root, it was using fsolve, kind of same sort of thing. Usually the way that I see it is like a comparison of what there's a new y and an old y. When they're close enough, then there's some tolerance that you hit the error. But it is giving us some kind of implicit integration, both with our DeepSeek Coder v2 and ChatGPT. This one has that root function. And that one, I think root is a root finding function similar to, find the root of a vector function. I think that it's like root. I think the latest recommendation is to use fsolve. I guess here we can choose the solver, give it a Jacobian. Maybe it's the same. Let's see, what's the difference? Fsolve and root. Back to Stack. This was my original ChatGPT, was Stack Overflow when I was learning how to code. So back to Stack Overflow. So this is saying fsolve is a wrapper for high BR, and then root, you can choose which one. So they're based like between this Ollama DeepSeek and then ChatGPT. They're both giving similar advice of like use some kind of fsolve or root finding method to get to that answer. Okay. Anyway, so next time I log on and record, I was gonna try like installing. Let's see how this one. Oh, now we have DeepSeek-R1. I wonder if this will work now. So clear that out and then say, I'm just gonna do a quick one. I need a Python function to print hello world. This one should be able, at least if we're connected to our DeepSeek R1. A lot of waiting around. Yeah, one of the things that I try to remind myself is that the AI model is not thinking right now. It's purely processing. It's taking this string of text, turning it into a vector, transforming that vector, and then doing some kind of processing to that so that it ends up with some kind of next word prediction algorithm. Python print function to print hello world. That's funny. That's a classic problem. This is a lot of information for a print statement. I mean, I guess that's good. Like, give you a lot of background behind where the code came from. It's probably pulling. It must have training data on Hello World from a few million different exercises. So it's really pulling from a lot of those introductions to Python. But anyway, next time I'll kind of rewind. I have another computer that I can stream from and try installing Ollama. So start from scratch again, and then get this. So this is something called like Jupyter Naut. So Jupyter NAUT is generative AI in Jupyter. There are ways to, nope, get rid of that. There are ways that you can say, let's go down here. I think you can have it connect to like your ChatGPT account, like if you want that interface. And then there's some other cool features where you can like train it on data that you're using already, and then these other things where you can like get it into your notebook as well. It's pretty exciting. But then there's also with Ollama, here if we go back to GitHub for Ollama, the thing that I was going to try was, so there's all these different models, and then there's even more that you can go and find. There's command line, and then there's also these like different desktop like user interface things, and I think this Open Web UI is kind of like a user-friendly, similar to ChatGPT, where it looks like a ChatGPT, but it's a website hosted on your own computer. So that's what I'm planning to try next time, see if I can get something like that up and running. And I thought some of the like building this is like, could I host my own server and run this, maybe give it a set of training data of these are some notebooks that I think are important, and this is what I want you to consider before or including the rest of your work. Okay, so hopefully you enjoyed kind of sitting around watching watching this thing. And yeah, here, this is a lot of information to get to this. And I think we can do this, like, oh, we could copy the response, the whole response. And can I paste it in here? V? No. Paste. Turn that into Markdown. Run that. Turn that into Markdown, and then we'll say print hello world. All right, it worked. Cool. All right, thanks for joining, and thanks for watching, and I'll catch you next week. Try something new.